Hi, good morning. Hello.
Good morning, ma'am.
Yes. We started class. So do you have any thing to discuss from the previous class? What are the things that affects the strength of concrete? Hello. Can you say what are the things that affects the strength of concrete?
Water to cement ratio.
Yeah. Hello. Your voice is not clear. Your voice is not clear.
Water to cement ratio.
Water to cement ratio. Okay. Other than that, so the porosity. Then the way you compact vibration affects the strength.
Quality of the raw material.
Quality of the raw material, yes. And then while doing testing, the load rate that you are applying for testing will affect your result, strength. And then the end restrainment, when you do testing, that will affect your strength. So basically in the last class, we looked at the hardened properties. So how do you evaluate the mechanical characterization of concrete and certain factors that could influence the test result or the compressive strength. So you may get false result when you are not following the protocols properly and you tend to assume that is the actual strength of your concrete and you will continue your design. So to avoid that, you should have awareness what are the things that can affect the performance of concrete so that you know if something goes wrong, why that is behaving in that way and how to fix it, right? So those are associated with hardened properties of concrete. So for you are clear with the concepts of fresh properties of concrete, and then we looked at hardened properties of concrete. Now we look at durability properties of concrete. So durability is the one that determines how long your concrete will stay. That means how long your concrete will survive without failing or deteriorating. Right? So in general, when you design the concrete, so in the previous, in the last decades, we give a lot of importance to durability as much as what we give for strength criteria. Before that, we only looked at strength criteria to define or to design the concrete. So as long as if your concrete is attaining certain particular strength that is specified, that is fine, people will just proceed with it. But later, even if your concrete has sufficient strength, it was observed that that fails. because of its durability issues. Okay, so in this lecture, we are going to look in detail what is the durability issue and what are the different factors that governs the durability performance of your concrete. Basically, when we say durability, we can split the concrete into two regions, especially the reinforced concrete. We can split into two regions because the durability of concrete plays a role when you have reinforced concrete system. If your concrete is not good quality, then that will affect your performance of concrete. Eventually that will affect the steel that is there embedded in the concrete. So to protect both, you should design your concrete in such a way that is durable. So here you can see a concrete cross section. You have your stirrups, that is steel reinforcement placed or embedded inside the concrete, and we classify this concrete region into two parts. One is the covercrete, that is outside your region, outside your reinforcement. The concrete that is outside in your reinforcement is called as covercrete. Basically, that governs the behavior of or the performance of durable concrete. And then you have something inside the steel reinforcement that is called hotcrete. I'll just so this is the heart of the concrete and which governs the strength. So we call it as hotcrete. Okay. So the one that governs the durability is called covercrete. For strength, your hotcrete should be strong, and for obtaining durability performance, your covercrete should be good. So we'll just look in detail. These are the outline of this module. First, give the general introduction, why durability is important, and then we will look at different mechanisms that will affect the durability performance of your concrete. It could be corrosion, so which would again first deteriorates the concrete and then it affects the steel reinforcement that is there. So corrosion is mostly associated with steel behavior. So if your concrete is not good, that will allow other elements like water or oxygen and chlorides and some carbon dioxide to enter into concrete. So if your reinforcement is exposed to water or oxygen, so water and oxygens are essential thing for corrosion, and chlorides and carbon dioxides that will also lead to corrosion and that accelerates the corrosion, and the corrosion due to chloride is called chloride induced corrosion, and corrosion due to carbon dioxide is called carbon induced corrosion. So all these things basically is going to affect your steel and eventually that will affect the bond between the steel and concrete. So any composite material or any structures where two different material works together, the bonding between the two material plays a crucial role to ensure the required performance. If bond is affected, then the composite action will be affected and then the load carrying capacity will be affected, right? So to ensure proper ductility and load carrying capacity, if you have a reinforced concrete system, the bond between steel and concrete is vital. So when you have corrosion, the bond will be affected. So we want to protect your system for a good performance and for long service life. In that case, you should know the mechanism that could affect or that could induce corrosion, and you should know how to avoid the corrosion to have a durable structure. And then chemical attack, most often your structures will be exposed to some aggressive environments, and if your structure is a chemical plant or any industrial structure, so there most often that will be subjected to aggressive chemicals in terms of sulfur, like you can your structure can be exposed to acidic environment, your structure can be exposed to sulfates you have if you have your structure like underground, or if your structure is when you have sulfates rich soil, then sulfate attack will be significant. And then we have some mechanical deterioration and long term, that is shrinkage and creep. So you are familiar with the shrinkage by now. We discussed in various aspects how shrinkage affects the fresh properties, all those things. Similarly, the shrinkage is not only governs or not only plays a role when your concrete is in fresh stage or hardened, but this also affects the performance when your concrete is in hardened stage. So likewise, based on its stages, we have different types of shrinkage classifications. So that will affect, influence the concrete over or at different stages, either when it is in fresh stage or when it is in hardened stage. So we will look in detail about the shrinkage mechanism and creep. So creep is nothing but when you have some element or the concrete structure under the sustained loading condition for longer duration, your structure tend to creep. So those we will discuss in the creep section, and we have ASR and freeze-thaw conditions that could affect the durability. So ASR is nothing but alkali silicate reaction, and freeze-thaw occurs in a cold weather region where your pores will get accumulated by water and it gets thaw. It really um, like water gets evaporated. So the cyclic reaction will induce certain stress concentration and that will affect your performance of concrete. Okay. First, let's look at the general thing why durability is important. In general, when we design, our concrete is an inherently durable material. Especially when we use for reinforced concrete structures, we expect the structure to be maintenance free during their entire life. Because once it fails, you have to do the repair work so often. So to avoid that thing, so for repairing work, you have to spend a lot of money in it and a lot of manpower involved in it. So while constructing on the stage itself, if you are using a durable concrete material, then your steel reinforcement will be protected for longer duration and your service life will be enhanced significantly. So the maintenance, to obtain the maintenance free service, like to obtain the maintenance free constructions during the service life, the durability properties of concrete plays a major role. So you have to select your concrete such a way that it is durable and it can protect your steel without requiring frequent maintenance, right? Of course you need to do maintenance, but that's once in a while just to check the condition of your structure. But if you are not using durable material, then before you do your maintenance work, you will start observing that your structure is deforming or your structure may deteriorate over the time. So to have a maintenance free structures, designing concrete plays a major role, or durability of concrete plays a major role. So most often we observe evidence of premature deterioration of modern construction. So we construct the structures to last for at least 50 plus years. If it is a building structures and if it is a huge infrastructure projects, we even construct buildings for 100 plus years, right? So in the recent construction that, like in India, you know the Ram Ayodhya temple. So there, it is proposed to use concrete that should last for 1,000 plus years. So imagine when we use the concrete that should last for significantly long period, then the expected performance from the concrete should also be significant to have a durable construction, right? So but recent times the materials that we use without having the awareness of durable, so just checking the cube strength, and if you use concrete in a construction, so you tend to observe a lot of premature deterioration. So this kind of structures you might have seen in bridge structures where you pass by, some structures may be deteriorating because of some issues. Maybe that would be due to the poor concrete usage, or that they may not, the structure was not used constructed using durable concrete. And then the cost involved is also high. So when you have deteriorated structures, then eventually we will end up repairing it. The resultant cost to the economy will reach about 3 to 5% of some countries GDP. Okay, so that is GDP, and up to 50% construction budgets. So in India, it is not in India, across the globe, it is estimated $2 million are spent for repairing construction work due to corrosion alone. So then imagine for when you account for other deterioration mechanism, the cost goes significantly high. The reason behind these repair works and the frequent maintenance works is because that we lack knowledge on this durability aspects of concrete. So most often when it is when the durability has to consider, it was thought that the durability is the only property that is a function of compressive strength of concrete. So if they do the cube, if the cube strength of the concrete is passed, then automatically it was assumed that your concrete in the structure is safe. But most often that is not the case. But one good property of concrete is very forgiving. So whatever you do, that will take care of itself. But then it has certain limit. So if that crosses the limit, then it cannot take what the things that we are harming to the concrete. Then it will start showing its sign and warnings to take care of it. So to understand the signs and warnings, you should know what exactly or how the mechanism behaves differently for different types of deterioration. So this represents the real scenario, especially when you have reinforced concrete member. You will have a concrete structures and you have your covercrete here, so which basically governs the durability performance. I will tell you why covercrete governs the durability performance in the coming slide, right? And you have your inner core concrete that basically called as hotcrete, which governs the strength of the concrete or the reinforced concrete member. So you know, in the concrete we have cement, water, supplementary cementitious material, aggregates, all those things. So for attaining the hardness, your cement has to hydrate and bind all the material together. Passive hydration results in decreased porosity and reduced interconnection of pores, that is fluid transmissibility. That means, so in the previous lectures, we looked at how the pores plays a major role, so that governs the density of your concrete. So as your cement hydrates, that fills the pores as much as possible, and when the pores are filled, your porosity will get reduced. And if your porosity get reduced and the proper compaction ensures the expel of unwanted air that is trapped in your concrete. So when you remove the air from the concrete, that again makes your concrete so compact, and there could be some small pores that is present in your concrete, but these pores may not be connected. So that is what meant by the reduced interconnection of pores. So to something to pass through or travel through, your pores should be connected. So if you have your concrete with pores, but if the pores are not interconnected, then also you can say your concrete is durable, because even if something enters, that will get trapped at that location. It cannot travel further inside your concrete, especially water. So when you have reduced interconnection pores, that will reduce the fluid transmissibility. So that can be water or that can be chemical. Basically, when you reduce the porosity and when you reduce the interconnectivity of pores, you reduce some transmissibility from the outside the environment to the inside concrete matrix. So there are different conditions and problems that you expect in RC members. So here is one example. You can consider this region as a concrete member. So this whole surface here. So this whole surface represents the concrete member, and then you have your rebar located here, and the location from the concrete surface to your outer rebar is basically called as covercrete, and then you have your hotcrete starting from this region. So that is your hotcrete. So most often your hotcrete will be in good quality concrete. So you will have good quality interior concrete in the bulk region, that is hot region, and then in the outside the covercrete There mostly you will have poor quality near surface concrete, especially when your curing is not adequate. So this we discussed in detail when we look at the properties of, like, why do we do curing and the properties of fresh concrete. So most often your surface is exposed to the atmospheric condition. So the water from your concrete during its fresh stage that tends to evaporate from the concrete to atmospheric conditions. So you can see your water is drying at the surface. So in that case, curing plays a major role. If you are curing your concrete adequately, that prevents any water evaporation from your concrete, and that may helps you to attain good quality near surface concrete. If you are allowing your surface to dry out, then water from the concrete evaporates, and then that will lead to shrinkage issues and plastic shrinkage at the surface. So the quality of concrete will be affected here, because when water evaporates, and that may lead to some pores in your hardened concrete, and then during its fresh stage itself, and then you will get tend to have lot of pores in the poorly, like poor quality regions. And again, this is the path where you have interaction with other aggressive agents. So this will lead to ingress of elements like chlorides, water, carbon dioxide. So to avoid that, it is very essential that your member or the concrete at this region should be in good quality, with less pores and with less interconnectivity. So what could be the cause? So the deterioration begins immediately after casting. So that is what I meant. During its fresh stage itself, when you expose your concrete to the atmospheric condition, you tend to observe such kind of plastic cracking, bleeding, segregation and thermal effects due to the, like, how do you mix your concrete, how are you going to handle your concrete, how are you going to place your concrete, right? So while doing all these steps, you should have things in your mind that your concrete should not be exposed significantly to the atmospheric conditions, and the way you handle should not cause any bleeding. If your concrete bleeds, then a lot of water will tend to come up, and then that will lead to evaporation. And if it segregates, then you can see a lot of honeycombs on the concrete surface, that basically represents a lot of voids and pores on the surface itself. So in that case, for other aggressive elements, it will be easy to enter into your concrete. And thermal effects. So thermal effects and plastic cracking, that goes hand in hand. When your member is exposed to atmospheric conditions due to high temperature or due to humidity conditions, your moisture will be evaporated, and then you will start observing plastic cracking. That is one way. And another thermal effect is because of this condition variation. So in some regions, the temperature will be too high in the daytime, and in some regions, in the same day, the temperature will be reduced significantly after evening. So this kind of thermal cycle could also affect your concrete performance. And hardened concrete, that will be significantly affected by the various factors internally as well as externally, which could cause damage by physical and chemical mechanisms. Okay, so this is like basically represents the pores and voids inside your concrete, and then the other aggressive elements that is there outside your concrete that could damage the to deteriorate the concrete. And most often, this deterioration associated with the increase of aggressive elements, especially when your near surface concrete is not in good quality. So that's why yeah, it is important to design the near surface concrete to be in a good quality, because that controls the durability performance, because that they are the ones, they are in the front line to fight with the aggressive agents. Thus that will help you to prevent the deterioration of concrete and enhance the durability performance of your concrete. And why this concrete plays a major role? Because that is the one that protects your steel. So why do we choose reinforced concrete member? First of all, because our concrete is weak in tension and good in compression. So we want to enhance the performance combined for compression and tension. So if you provide steel in your concrete, then the member acts as a composite member, so the steel kind of take care the concrete's weakness. So the steel will help your concrete to take, or the system to take more tension also, by enhancing its capacity, and it undergoes lot of energy absorption before the member fails. So the ductility will also be increased when you provide reinforcement. So for meeting all this requirement, your reinforcement should be well protected from the aggressive environment, especially like the scenarios where you have a chloride rich environment, or where you have carbon dioxide rich environment that could cause corrosion of your reinforcement. So for that reason, adequate protection of steel is required, and that will be offered only by the covercrete of your concrete. That's why the covercrete controls the durability performance of concrete, and you have to give a lot of importance to covercrete while you are going to place your concrete in aggressive environments. So we can split the durability aspects into two categories. One is fully focusing on the concrete system alone. What are the things that we can do to have a durable performance? And then other external factors. So one governs the internal factors associated with the concrete, and the other one influenced by the external factors. So that can be physical or chemical attack, right? So here you can see in the material process you have binder type, and the binder type that you choose that plays a role in affecting your durability performance. So if you use only cement material, and if you use both cement and supplementary cementitious material, your concrete will behave in a certain way. Why? Because in supplementary cementitious material you have what property? Pozzolanic reaction you have, so pozzolanic property you have, as well as filler property you have. So when you have pozzolanic property, so this reacts with, it is going to react with your hydrated product, cement product, that is that reacts with the calcium hydroxide, and that produces additional CSH gel, and that could fill the pores in the matrix, as well as this acts as a filler. So the finer pores in the matrix will get filled by this supplementary cementitious material. So the type of binder that you use affects the durability performance, and the binder content. Again, the binder content, amount of binder that you are using will affect the durability performance. More the binder, so the water requirement will be more, and eventually that plays a role in affecting your durability performance. In certain case, when you have more binder, you will not have enough water to cure or induce the proper hydration. So if you have unhydrated cement in the matrix, and if that cement reacts with water in the later stage, when the water entered into the concrete, that will affect your performance significantly. So all these things plays a role when you concern about the durability performance of concrete. And then aggregates that you are using, so there are certain aggregates that are reactive, and there are certain aggregates that are less reactive. So when you use most often we use aggregates that are available in the nearby construction location. That's why we use aggregates, because if you use local material, that will be very economical for your construction. So in that case, you have to see the aggregates available in your locality and the nature of aggregates available in your locality. So whether it is reactive or non-reactive. If it is reactive, then you have to take measures to avoid the consequences of the reactiveness of aggregate that you are going to use. So you should know the type of aggregates that you are using, and admixtures. So this admixtures again, so we in the chemical admixtures part, we looked at the different types of chemical admixtures and their applications. So there are some regions where we need to accelerate the reaction, and there are certain applications where you need to retard reactions, and there are certain applications where you have to provide spaces to release the stress. So those comes under category when you use freeze thaw, where when you have to design your concrete for freeze-thaw conditions. So if you are not considering those factors, and if you are not including those admixtures in the given applications, then that may result in some failures. So you should know, if you are designing in that particular applications, appropriate admixtures should be used, and mixed design. So everything governs by the mixed design, how you are going to proportionate these ingredients in your concrete. So that's all with the material process, and then you have that's all with materials, and then you have the process. How are you going to mix your concrete, and how are you going to transport concrete from one region to one place to other? While transporting, you should ensure that the way you transport should not create bleeding or segregations, or it should not allow any water loss by evaporation of water. So all things should be considered. And the compaction, how we are going to compact your concrete, under compaction or under vibration or over vibration will affect your strength and durability performance. And the curing, because curing governs the quality of your near surface concrete. So you should allow curing as long as possible until your concrete becomes or concrete reaches its sufficient strength and required performance, and temperature to be maintained for hydration process, and workmanship to take care of the all this process, mixing and transportation and compaction, right? And now let's look at aggressiveness of the environment, and there that depends. One is physical condition and chemical conditions. In physical conditions, the way like if you have the hardened surface, and if vehicles pass by, or if there are any huge load that is passing by, and that may induce abrasion and erosion and cavitation. All these things are similar. Sometimes this cavitation and erosion most often associated with water pressure. So when you have surface where you have continuous flow of water, there you observe not only continuous flow of water, if you have continuous movement of any rough particles, that could that could result in this erosion and cavitation attack. And then you have freeze thaw cycle, so that because of the temperature variation, you have this freeze thaw effect. And then you have chemical deterioration. So there, the concrete matrix get dissolution, and then that could react with the calcium hydroxide. In cement, I have already mentioned calcium hydroxide. CaOH2 is the weakest link, and any chemicals that enters into your concrete that most often reacts with the CaOH and results in dissolution and leaching of your concrete. In some cases, some elements that could react with the CSH, and that will change the binding property of cement itself. In that case, the binding property will be affected. So the binding will be affected significantly, and you will see this disintegration of the part ingredients and the expansion. So in case of ASR, your aggregate is in reactive state, so that reacts and that produces expansive gel. So when you are in a hardened concrete, when you have something like expansive gel product formation, or any expansive stresses induced, and that will lead to significant tensile stress that could crack your concrete. So expansion will be the result of chemical. And alteration is what I told. The CSH properties may be changed, so the binding property itself will be changed, and they could alter the conventional cement properties. Okay, I'll just have a 10 minutes break, and then we can start from this. Okay.
Okay, ma'am.